All right, we have a dynamics question here about a block moving with initial speed v and it's brought to rest after traveling a distance d by a frictional force small f. The second block has initial speed u and is brought to rest in the same distance by the frictional force F/2, and we're asked what is u. I'm assuming you've had a go at this question, so let's have a look at what's going on here. To solve this one, we're going to use energy conservation. Okay, we're going to start with the first block, and we're going to call that block number 1. And what you can see here is I've calculated the work done. The work done on block 1 is just the force times the distance, and we're going to assume that those two forces and distances are in the same direction, which seems to make sense. Frictional force. Now the force times distance is the work done, and the work done is equal to the change in energy. So in this case, it's the kinetic energy that's changing. Half mv squared. The half mv squared is going to decrease until our block stops. So the work done must equal the change in energy. Fd is equal to a half mv squared. Now, we can do the same for block number 2, except this time the force is simply F/2, and we have an initial speed u, which then leads to half mu squared. So we've got two equations now, and you'll notice that I've highlighted FD in red. That's because we're going to do a bit of substitution to find the relationship between V and U. Okay. Hopefully you can see that if I compare equations 1 and 2, I find that the amount of work done, FD, on the first block is double the amount of work done on the second block. Or, in other words, the amount of work done on the second block is half that done on the first block. So that means that half mu squared, that's the change in kinetic energy in the second block, is equal to half of the work done on the first block. And so therefore, a half mu squared is equal to a half mv squared. Now these things are identical, meaning their masses can cancel. And therefore, we would have a relationship which is simply that u squared is equal to a half v squared. In other words, u is equal to v divided by the square root of 2. And that is our answer B.